Hey everyone, this is Tyler Berry back for another whiteboard session. Today we're going to be talking about hydropneumatic tanks when it comes to booster pump applications. Why do we need a hydropneumatic tank? Well, for any given commercial building, we don't really have a case a lot of times where we have a zero flow, zero demand situation. There's always going to be somebody opening a hand sink, flushing a toilet valve, or maybe you just have a leaky faucet or something like that going on in the building. For these reasons, we use a hydropneumatic tank on the discharge of a pump to satisfy those light demands and to keep our booster from constantly cycling. So the two main criteria for sizing a hydropneumatic tank for booster pumps is the location of the pump and the amount of time you want that booster pump off. Now, a lot of times people will say that 3 minutes is absolute bare minimum for having the pump off. And a lot of times you want to have it off for a lot longer than that, even closer to 30 minutes, because the more we can keep it off, the less cycle time of the pump, the more energy we're going to save. So in part 2 of this series, we're going to talk about kind of the pressure relationship and the fill pressure of these tanks as it relates to booster pump sizing. But just keep in mind that typically we don't see this tank location for a variety of reasons. It does result in the smallest tank, but a lot of times we don't have the space available to actually put that tank where we need it. And a lot of times we see tanks in these applications or in these locations of the system, primarily because they're right next to the booster pump, easily accessed, easily set. And the only difference between these two is that if you have a very tall building, you really want to have this tank after that PRB that we noted here, because that could probably change your system class working pressure classification. Just keep that in mind. Part 2 will go over pressures a lot more. But in an example of where you can pull down tank sizing from different manufacturers and charts and stuff like that is this brief table based on the demand, GPM, and the application type in terms of building type. Now, the reason why there's a huge disparity between these numbers is just the diversity factor in which the application is required for each one of these systems. This is why an apartment is way less than a hospital. But we talked about energy savings, we talked about time off. So let's say 15 minutes is the compromise you came up with as an engineer to keep the cycle time down. To do an adjusted acceptance volume, based on this chart, you would do adjusted acceptance volume equals the desired shutdown time divided by 30 minutes times the acceptance volume. Pulling from this table up here, 300 GPM for a hospital for 15 minutes results in a 180 gallon acceptance tank. Similarly, if we took that same example and did it for an apartment, we're all the way down at 22.5 gallons. So you can see, based on the diversity factor of the application and also the location of the tank, which we'll go over next time, it makes a big impact on the tank sizing and how much acceptance volume you need. So that's just part 1 of this series. I hope you learned something. If you have any questions about booster pumps, hydropneumatic tanks, their locations, different applications, just give us a shout. Appreciate your time.